Chapter 1, Lesson 2 of Pre-Calculus, going to do some examples where we determine whether the function is odd, even, or neither by substituting in negative x. And just graphically, I have three choices here. You'll notice that this graph here is the same on the left side of the y-axis as it is on the right side of the y-axis. So it's symmetrical with respect to the y-axis. Therefore, this would be an example of an even function. You'll notice that this parabola, while it is symmetrical by itself, meaning if you drew the axis of symmetry, it is symmetrical. It is not symmetrical over the y-axis, meaning you can't put in, if I were to take 4 here, if I put in negative 4, I would not get the same y value. So even though the function itself is symmetrical, it's not symmetrical with respect to the y-axis or the origin, so this would be an example of a neither. And then this function here is a cubic function, and again, if you imagine spinning that function 180 degrees around the origin, you'd end up with the exact same picture. So this would be an example of an odd. So those are the graphical representations. Let's go ahead and do a couple algebraically. So here is a function, and remember, in order to do this algebraically, we're going to substitute in negative x and then simplify it and see if we either get the exact same function, making it odd, or every term is the opposite, making it even. No, I had that backward. Everything is the same is odd, everything is the opposite would be even. So I'm going to put in negative x for x here, so it's going to be negative x cubed plus 0.004, and then I'm going to put in negative x squared plus 3, and then I'm going to simplify it. So negative x cubed is negative x cubed plus 0.00, sorry for my sloppy writing, I'll do better. Negative x times negative x is positive x squared plus 3. So now I want to look at this function. Is this function exactly the same as the one that I began with? Well, no, this is positive x cubed, this is negative x cubed. The other option is are all of these terms exactly the opposite? Well, the first terms are opposite, the second terms are the same. So the function is not the opposite, so it is not odd either. So because this is neither, or it does not fit either one of our solutions, this would be a function that is neither odd nor even. Okay? Thank you very much. Okay, let's do this next one here. So here's another function. So again, I'm going to put in negative x for each x. So this is going to be negative x cubed, and then I'm going to simplify the expression. So negative x times negative x is negative x. So this is going to end up being negative 2x cubed. The x cubed is x cubed, the negative sign cubed is a negative sign, so that ends up being this. Now here I have negative 3 times negative x, so this ends up being positive 3x. So now the two scenarios. Is this function the exact same as what I began with? No, so it's not even. Is this function the exact opposite of what I began with? Well, the first terms are opposites, 2 and negative 2. The second terms are opposite, 3 and negative 3. So because when I put in negative x, I got the opposite function of what I began with, this would be considered an odd function or symmetrical with respect to the origin. Okay? Then the next one. Oh, thank you very much. Okay, so if we look at this one here, again, we're simply going to substitute in negative x and simplify it. So 3 over 1 plus, and then negative x squared, and then I'm going to simplify it. It's going to be 3, and this is going to be 1, and then a negative x times a negative x is a positive x squared. So you'll notice that even though I put in negative x, I end up with the exact same function that I began with, and if I end up with the exact same function that I began with, that means the function is even. So even would be the correct answer here. Okay? Thank you. All right, let's do one more, and then we'll hopefully you'll have the idea. So we're going to put in negative x. So we're going to put in negative x cubed, all right, over 4 minus, and then negative x squared. What are we going to get? So the negative x cubed ends up being negative x cubed up here, and then this is 4, and then negative x squared, that's going to be 4 minus x squared. So now this function, is it the same as what I began with? No. Is it the opposite what I began with? Now this is kind of tricky, is it? Because remember, if one of these is negative, if the numerator or denominator is negative, that means the entire thing, I could rewrite it as this, okay? Which means I have the opposite of what I began with. So this function would indeed be the opposite, which makes it odd, okay? So that's how you do those examples. And oh, yes, thank you. You're a little late on that, but yes, you should be cheering because that's kind of a tough one, okay? So be careful with the fractions. Remember, if just one of them ends up being the opposite, or the numerator ends up being the opposite of what it was, or the entire denominator ends up being opposite of what it was, then the entire function is opposite, because that is a division problem, and a numerator, a positive numerator divided by a negative denominator is negative, so it ends up being opposite. Okay, so hopefully that was helpful, and good luck with the rest of the lesson.